Good morning, Junior 6. Can you listen me? Stop writing on the screen. Today we'll start in the new lesson on Unit 1, Law of Levers, okay? Law of Levers. In this lesson, we will study In this lesson, we will study the levers in details. At the previous lesson, we know the meaning of the effort force, resistance force, and fulcrum, okay? And we know that the lever is a rigid bar that rotates around a fixed point. This fixed point is called fulcrum, and it's affected by effort force and resistance force. If the effort force on the object the effort force on the object may be equal to the resistance force, or more than the resistance force, or less than the resistance force, okay? In this activity, we will determine the effort force and resistance force, and we will know the effort arm and resistance arm. Determine the weight of one of the objects and let it be your school bag using the spring scale. The weight indicates the value of the resistance. Okay, here, can you see this image for boy? This boy hold a spring scale. This spring scale is hanged on the holder. This point is called in the midpoint is fulcrum, and in the another side of the holder there is a bag. This bag contains a weight. So when the boy starts to move this spring scale, when the boy starts to move this spring scale, the boy makes an effort force. The boy makes what? Effort force. Okay, so the effort force by boy, but this bag have a weight, so it has a resistance force. So here is an effort force and here is a resistance force. This point is called a fulcrum. From this point, from the spring scale to the fulcrum, this distance is called the effort arm. From the spring scale to the fulcrum, this distance from the spring scale to the fulcrum, it's called what? Effort arm. Okay, this point called effort arm. Okay, but in this point from the back to the fulcrum, it's called the resistance arm. So again, the boy hold a spring scale on your hand, okay? The distance between the spring scale to the fulcrum is called the effort arm, is called the effort what? Arm. And in the another side, there is a bag. This bag contains weight. The weight of the object is a resistance force. So from the bag to the fulcrum is a resistance arm. From the bag to the fulcrum is a resistance arm. Okay? In this activity, we will take the effort force and resistance force, effort arm and resistance arm. And we will repeat this step for many times by using, instead of the instead of this bag, different materials, okay, and move the spring scale from this position to back and front. It's okay. And take the effort force, resistance force, effort arm, resistance arm in each time. Again, in this lesson, we will study the law of lever. From this activity, again, عشان في ناس مش فاهمة. From this activity, we will repeat. In this activity, we will know the meaning of effort force, effort arm, resistance force, resistance arm. It's okay. This boy hold a spring scale in this side, and in the another side there is a bag. All of these holding by the point in, it's called a fixed point in the center, okay? The fixed point in the center is called a fulcrum. The boy starts to move this spring scale to take the reading. When the boy starts to use this spring scale, the boy makes an effort force. The force is that exerted by a person. So by the boy, it's called the effort what? Force. And the force of this bag, it's called a resistance force. It's called a resistance force. So here effort force and here resistance force. The distance from the boy, from the spring scale to the fulcrum, it's called the effort arm. From the bag to the fulcrum, it's called the resistance arm. Again, from the boy to the fulcrum, by the meaning of from the effort force to the fulcrum, it's called the effort arm. From the resistance force to the fulcrum, it's called the resistance arm. It's okay. I will repeat this step for many times by using different materials. To take the reading in each time, the reading will be different. Okay? Here, the effort force at the first time is 50. The effort arm, 40. Resistance force, 50. Resistance arm, 40. So, the effort force is equal to the resistance force. The force doing by a person is equal to the resistance force of the body. In the first time, effort force equal to the resistance force. When the effort force equal to resistance force, so the arm of force equal to the arm of resistance, okay? By the meaning of when this force equal to this force, so this distance equal to this distance. It's okay? When this force equal this force, so this arm equal this arm. Effort force equal resistance force, so effort arm equal resistance arm. Here, effort force by 50, resistance force 50. Effort arm 40, resistance force 40. Okay? Again, by changing in the second step, by changing the weight of the object and changing the position of the spring scale. When I take the effort force for the second time, ياسين انت بعت لي مش فاهم وانا بعيد تاني ياسين, okay? When the effort force in the second time equal 60, equal what? 60 in the second time. The resistance force equal 120. So the effort force doesn't equal to the resistance force, okay? So the effort arm 30, the resistance arm 15. So the arms are different. So when the effort force equal to the resistance force, the effort arm equal to the resistance arm. When the effort force is different to the resistance force, the arm of force is different from the arm of resistance, okay? You can imagine this by fulcrum here, okay? Effort force here, resistance force here, okay? This distance, it's called effort arm. This distance, it's called the effort arm. And this distance, it's called the resistance arm, okay? So, effort force here, resistance force here, the distance between effort force and fulcrum, it's called effort arm. The distance between the resistance force and fulcrum, it's called a resistance arm. You understand? Okay. The effort force may be equal to the resistance force. The effort force may be equal to the resistance force. I will do the effort equal to the weight of the object. So the arm of force equal to the arm of resistance. In second, I will do effort force equal 60, the resistance equal 120. By the meaning of I am doing a little effort. I'm doing what? A little effort. But the weight of this object or the resistance of the force of this object is more than the effort that can I do. Okay, the effort force I do the effort equal to 60, but the resistance is very big, but I do a little what? Effort. So when I do this little effort force and the resistance is bigger, than the arm of force is different to the arm of resistance. The arm of force is equal 30, the arm of resistance is equal 15. This means that when the force is very small, when the force is small, when the effort force is less than the resistance force, the arm is big. So it means when the effort force is small, the effort arm is big or large, okay? When the resistance force is large, the arm is small. So the arm is opposite to the force. The arm is opposite to the force. When the force is large, the arm is small. When the force is small, the arm is large, okay? Third, here, the effort force equal 70. The resistance force equal 35. Which one is bigger? The effort force. I'm doing more effort. I'm doing more effort, okay? So the effort force is bigger than the resistance. I'm doing a big effort. So the effort force is bigger than the resistance force. So the arm is opposite. When the effort force is big, the arm is small. The arm is what? Small. When the resistance force is small, the arm is big. Okay? I will repeat all of this from the beginning again. I will repeat all of this from the beginning again. Focus with me, okay? In this lesson, we studied something which is called the law of levers, okay? At the previous lesson, we know that the effort force, resistance force are two forces affected on the affected on the lever. The effort force is a force by a person. The resistance force is a force, the weight of the object, okay? Maybe the effort force bigger than the resistance. Maybe I'm do an effort is very big comparing it to the resistance force. Or maybe I will do the effort force which equal to the resistance force. Or I will do an effort force which is less than the resistance force. So the forces may be equal, or maybe the effort more, or maybe the effort less than the resistance. It's okay? Okay. Here, in this activity, I will determine the weight of the object and I will determine the effort that I will do on this object, and I will determine the distance between the effort and fulcrum and resistance and fulcrum, okay? When this boy use this spring scale, the boy make an effort force, okay? And this bag have a resistance force. Maybe the effort of this boy equal 50, and the resistance equal 50. So the boy make an effort force which is equal to the resistance force. Okay? If this boy make an effort force which is equal to the resistance force, so the arm, the distance from the spring scale, to fulcrum equal to the distance from fulcrum to the object. So the effort arm equal to the resistance arm. Again, I said before, from the effort force to fulcrum, it's called the effort arm. From the resistance force to fulcrum, it's called a resistance arm. It's okay? When the boy do an effort which is equal to this resistance force, so this arm equal to this arm. It's okay? But if the boy make an effort force 60 and the resistance force 120, so the boy make a little effort. This boy make what? A little effort comparing to the resistance force, okay? Which one is bigger? The resistance force is bigger, okay? The arm is opposite to the force. When the force is bigger, the arm will be very small. When the resistance bigger, the arm will be very small. When the effort small, the arm will be big. Arm opposite to effort. So look at number 2, effort 60, resistance 120. Which one is bigger? The resistance force 120. Okay? Which one is bigger? The resistance force 120. So when the resistance force is bigger, this arm is small. So the arm of this 15, but this 30. It's okay? Third, the effort force 70, resistance force 35. So the effort force is big. So the arm of force is small. Here 20, here 40. Okay? All I wanted to know from this, that when I take the effort force, effort arm, resistance force, resistance arm, when I make times effort force times its arm, resistance force times its arm, and each time will be equal. Force times its arm, when we make 50 times 40, it will be equal 50 times 40. It's okay, 2000, 2000. Here, 60 times 30 equal to 120 times 15, 1,800, 1,800. So each time the effort force times its arm equal to the resistance force times its arm. From here we know the law of lever. From here we know the what? The law of lever. The law of lever says just wait. The law of lever says the effort force times its arm equal to the resistance force times its arm. Effort force times its arm equal to the resistance force times its arm. In these problems, he gives me 3 of them and asked me about the force 1. Gives me such example, effort force, arm, resistance force, and asked me about its arm. We will solve our problems on this. But open your booklet, page 12. Effort force arm is the distance between the effort force and fulcrum. The distance between the effort force and fulcrum. Resistance arm is the distance between the resistance force and fulcrum. يبقى the distance between effort force and fulcrum, force arm. The distance between resistance force and fulcrum, resistance arm. When the force arm and resistance arm are equal, when the arm equal to another arm, so the force will be equal to another force. يبقى when force R equal to resistance arm, the effort force equal to the resistance force. Okay? When the force arm is longer than the resistance arm, Miss Amira said that if the arm is bigger, the force will be smaller. So when the force arm is longer, so the effort force is smaller. When the force arm is longer, so the effort arm will be smaller. It's okay? Here, when the force arm and the resistance arm are equal, the effort force are equal to the resistance force. When the force arm is larger, so the effort force is smaller, force opposite to the arm, okay? When the force arm is shorter than the resistance force arm shorter, force opposite to arm, okay, so the effort force is larger. Again, force arm equal to the resistance arm, effort force equal to the resistance force. Force arm equal to the resistance arm, effort force equal to the resistance force. Force arm longer, effort force smaller. Force arm shorter, effort force larger. Okay? So when the force arm equal to the resistance arm, this lever doesn't conserve effort. What is meant by doesn't conserve effort? Doesn't save effort. I will do an effort which equal to the resistance arm, resistance force. I will do an effort which is equal to the resistance force. So when the effort equal to the resistance force, okay, so I can't save any effort. So doesn't conserve effort, doesn't conserve effort by the meaning of can't save effort. When the force arm is longer, the effort force will be smaller. When the effort force will be smaller, has a meaning I will do a little effort comparing to the resistance force. I will do a little effort, so I save my effort. I will do a little effort means I save my effort. So this lever conserve effort. The third one, the force arm is shorter, so the effort force is larger. The effort force is larger than the resistance force. I do more effort, so I can't save any effort. It's okay? Repeat it again. Understand Junior 6? Junior 6, could you listen me? Which page? Bilal, which page? Page 13? Okay, Bilal, I will repeat it for you again. Page 12. Just wait. 12. Okay. 12 definitions. The distance between the effort force and the fulcrum, it's called effort arm. As I said before, look at this point with me now. Here, fulcrum. It's okay? Here, sorry, fulcrum, effort force, resistance force. The distance between, this distance between the effort force and the fulcrum, it's called effort arm. This distance is called the effort arm. And the distance between resistance force to fulcrum, it's called the resistance arm. Okay? When the effort arm equal to the resistance arm, the effort force equal to the resistance force. When the effort arm is larger or longer than the resistance arm, effort arm longer, so effort force smaller. Arm opposite to force. When the effort arm or force arm, effort arm similar to force arm. When effort arm or force arm longer, so force arm smaller, okay? When force arm shorter, so effort force bigger, okay? So when they are equal, I can't save any effort. Can't save any effort. They are equal. I do a little, an effort equal to the resistance. So I can save effort, okay? When the effort force is smaller, I can save effort. I do a little effort comparing it to the resistance force. When I do a little effort, I save effort, okay? Number 3, when the effort force is bigger, I can't save any effort. I do more effort, so I can save it. Understand? You should know the rule. Effort force times its arm equal to the resistance force times its arm. Next session, inshallah, we will solve all problems on this rule. Okay? Thank you, Junior 6. Goodbye.